In this example, we need to list the first several terms of the sequence of partial sums for the given series, and we need to determine whether the series is convergent or divergent. Our series is the sum from n equals 1 to infinity of 2 divided by n squared plus n. I want to point out that for each series, we have two sequences associated with that series. We have the sequence of terms, and typically we notate the terms by a sub n. So a sub n is 2 divided by n squared plus n. So we can list several of these. A sub 1 is 2 divided by 1 squared plus 1, which is 1. A sub 2 is 2 divided by 2 squared plus 2, which is 2 divided by 6, or 1/3. A sub 3 is 2 divided by 3 squared plus 3, which is 2 divided by 12, or 1/6. A sub 4 is 2 divided by 4 squared plus 4, which is 2 divided by 20, or 1/10. A sub 5 is 2 divided by 5 squared plus 5, which is 2 divided by 30, or 1/15. And we know that we could keep going if we wanted to. So that's the sequence of terms. In addition, we have the sequence of partial sums. So we typically notate this with s sub n. I like to use a capital N so that I don't get it confused with the lowercase n we have in our original problem. Our s sub n is the sum from n equals 1 to capital N of 2 divided by n squared plus n. So the idea here is we are adding together the first n terms in the sequence of terms. So our first partial sum, s sub 1, is equal to a sub 1, which is 1. Our second term, s sub 2, is equal to a sub 1 plus a sub 2. So the sum of the first two terms, which is 1 plus 1/3, or 4/3. The third term in our sequence of partial sums is the sum of our first three terms, which is 1 plus 1/3 plus 1/6, which is 3/2 altogether. The fourth term in our sequence of partial sums is a1 plus a2 plus a3 plus a4, which is 1 plus 1/3 plus 1/6 plus 1/10, which altogether gives us 8.5. The fifth term in our partial sum is a1 plus a2 plus a3 plus a4 plus a5, which is 1 plus 1/3 plus 1/6 plus 1/10 plus 1/15, which altogether gives us 5/3. Now, we would like to make an educated guess about whether the series is convergent or divergent. To think about the sequence of partial sums more easily, it might make sense to think about these numbers as decimals. So we know 4/3 is about 1.33. We know 3/2 is 1.5. 8/5 is 1.6. 5/3 is about 1.67. And then if we look at the terms in this sequence of partial sums, it appears that they're getting larger and maybe approaching a value around 1.8 or around 2 And while we certainly don't know for sure quite yet, we think that maybe our series converges. In order to determine whether the series is convergent or divergent, we need to know whether the limit as n approaches infinity of the sequence of partial sums exists. So let's see if we can rewrite our terms so that the sequence of partial sums is easier to understand. So our term, what I was calling a sub n before, is 2 divided by n squared plus n, or in other words, 2 divided by n times n plus 1. Now remember when we did integrals, if we had a rational function, we would factor the bottom and do partial fractions. We're going to do exactly the same thing. So I'm going to write this as a over n plus b divided by n plus 1. And then I'm going to take this equation and solve for the coefficients a and b. Multiplying both sides by the common denominator gives us 2 equals a times n plus 1 plus b times n. Distributing the a gives us 2 equals a plus bn. Equating coefficients, if we look at coefficients on n, we have 0 on the left side and a plus b on the right side. If we look at the constants, we have 2 on the left side and a on the right side. So we know that a equals 2, and plugging in 2 for a tells us that 0 equals 2 plus b, so b equals negative 2. So we know that a sub n is 2 divided by n minus 2 divided by n plus 1. Now let's look at our sequence of partial sums. S sub n is the sum from n equals 1 to capital N of the term a sub n, or with our new expression, is the sum from n equals 1 to capital N of 2 divided by n minus 2 divided by n plus 1. Now what I'm going to do is write out several of these terms. So if n equals 1, we have 2 divided by 1 minus 2 divided by 1 plus 1 is 2. That's our first term. To that we add our second term, which is 2 divided by 2 minus 2 divided by 2 plus 1 is 3. Our third term, I'm plugging in 3 for the lowercase n. We have 2 divided by 3 minus 2 divided by 4. Our fourth term, we plug in 4 for n. 2 divided by 4 minus 2 divided by 5. This keeps going. I'm going to write out the second to last term. The second to last term is a sub capital N minus 1. So I'm plugging in capital N minus 1 in place of the lowercase n's. We have 2 divided by n minus 1 minus 2 divided by n minus 1 plus 1 gives us n. And our very last term in the nth partial sum is a sub n, which is 2 divided by n minus 2 divided by n plus 1. Now what we can see, because many of these terms are positive and many of these terms are negative, that we get a lot of cancellation. So the negative 2 divided by 2 and the positive 2 divided by 2 cancel out. Similarly, the negative 2 divided by 3 and the positive 2 divided by 3 cancel. The negative 2 divided by 4 and the positive 2 divided by 4 cancel. Negative 2 divided by 5 will cancel with a positive 2 divided by 5 that's somewhere in this middle part that I haven't written down. We'll have a whole bunch of terms in the middle that cancel one another out. And then, if we start from the right end, we have a positive 2 over n and a negative 2 over n that cancel. This positive 2 over n minus 1 will cancel with the previous term in here that we haven't written down. All in all, everything has canceled here except the first term, 2 over 1, and the last term, minus 2 divided by n plus 1, which of course is just 2 minus 2 over n plus 1. Now this expression is much easier to understand. We know that as capital N approaches infinity, the fraction 2 divided by n plus 1 approaches 0. So we have the limit of 2 minus 0, which is 2. This tells us that the series is convergent because that limit exists. Notation-wise, we write that the limit as n approaches infinity of s sub n equals 2, or, in other words, the sum from n equals 1 to infinity of 2 divided by n squared plus n equals 2.